All right, guys, we're going to be doing 6.5 solving radical equations. Again, our mission today is I can solve equations that involve radicals. So we're talking about solving equations. Basically, the goal is always the same, to try to isolate the variable and find the value of the variable that will make the statement true. So let's just go ahead and fire right in here and look at the first one. Our first example is going to be the square root of x equals 9. So I want you to think about what really is being asked here. What's being asked is, what can I take the square root of and make it to equal 9? You may already know the answer, but let's kind of just walk through the process itself. So remember, anytime, for example, if I had x plus 2 equals 4, in order to solve that, I have to do inverse operations in order to isolate this x right here, right? So I would need to subtract 2 in order to get this x by itself, which is in fact going to be 2, which makes sense. 2 plus 2 equals 4. Well, the same is true here. I need to isolate this variable x. In order to do that, I'm going to have to get rid of this square root sign, right? The square root sign is really what's kind of messing me up here. And so what is the opposite, or what is the inverse of squaring something? Or how do I get rid of a square root? Well, let's just take, for example, for just a second, if I had the square root of 3, if I multiply that by the square root of 3, then I'm going to get the square root of 9, which in fact gives me square root of 3. And we saw this by rationalizing denominators. We have it when we had radicals on the bottom of a fraction. We realized that we had to multiply by the same thing in order to get it. So basically what we're doing is we're squaring a square root. And when you square a square root, it basically does away with all of that, and it just leaves you with the number that's inside. Well, that's exactly what we need to do here. In order to get rid of this square root sign, I actually need to do the inverse of squaring, taking the square root of something, which is squaring something, okay? So if you think about it, if I take the square root of x times the square root of x, well, that's just going to give me just plain old x. The square roots are going to go away. So what I need to do here, I'll clean this up just a little bit so you can kind of see what's going on. I've got the square root of x equals 9. What I really need to do is I need to square the left side of the equation. But remember, equations must be balanced. So if you square one side and you don't square the other, then all of a sudden my equation is no longer balanced, and I've actually changed my answer in essence. So what I need to do over here is I need to square this as well. So what's going to end up happening is, on the left side, all of this is going to go away except the x, which is exactly what I wanted. And then I'm going to get 9 squared, which is 81, which again makes perfect sense. Because if I put this answer back into my original problem, the square root of 81 does in fact equal 9, okay? So you see how that's a pretty simple problem, but again, it's just using inverse operations, which is something we've been doing forever when we're talking about solving equations. So let's look at number 2. I've got the square root of x minus 2, and that is equal to 7. Again, notice that I have this square root equation or expression over here on the left side that's kind of isolated out to itself. So I've got to get this x by itself, but first I've got to get rid of this square root symbol. Well, again, what's the inverse of taking the square root of something? Well, it's squaring it. So again, all I'm going to do in order to solve this is just square this whole thing. And again, if I do it to one side, I have to do it to the other. So that means I have to square this as well. Notice what happens here. I get rid of everything. I get rid of the square root and the squared. And the only thing I have left is what is left underneath the radical. So I actually have x minus 2 that is left. And then here I have 7 squared, which is 49. So again, all I have to do in order to finish this out is the same thing I've been doing, again, since probably 6th grade, is isolate this variable of x here, which means I'm going to add 2 to both sides. And that is going to give me x equals 51. And again, I'll do this one more time just so that you can kind of see what's happening here. If I take 51 minus 2, that equals the square root of 49, which in fact does equal 7. So you can see how that it again kind of checks off that it is in fact the correct answer. So let's take it up one more step. Actually, I've got 3 more problems we're going to do. Number 3 is 5 times the square root of x equals 30. Again, I've got to isolate this variable right here. This is what I'm trying to isolate, but I want you to notice that I have multiplication between the 5 and the square root of x. So one of the things that you have to make sure that you do is you need to isolate the radical. Let me go ahead and write that over here as well. You need to isolate the radical on one side before squaring. Okay, so one of the first things I have to do is if I've got something else with my square root symbol, I've got to get rid of that first. Well, what is the opposite of multiplication? Well, the opposite of multiplication is actually division. So I'm going to first divide by 5 on both sides. And I notice what that does for me. This will cancel out, and I'm going to be left with the square root of x equals 30 divided by 5, which is 6. Now that I've got my radical isolated on one side with my variable, I can go ahead and square this. If I square one side, I have to square the other, which means I'm going to end up with x equals 6 squared, which is 36. And again, if I substituted that in, the square root of 36 is 6. 6 times 5 is, in fact, 30. So this answer checks out as a correct answer. All right, only 2 more to go. So number 4, we actually have the square root of x minus 1 plus 5. Notice the plus 5 is outside of the radical, and that equals 6. Again, I have to make sure that I isolate this radical portion of my equation or expression first in order that I can solve. So the first thing I actually need to do is I need to subtract 5 from both sides and get this 5 moved over here to the other side. So I'm going to end up with the square root of x minus 1 equals 1. And again, once I have the radical all isolated on one side, all I need to do is just square that portion, which means I need to square the other side as well. The only thing I'm left with is the part that's underneath the radical, so I end up with x minus 1 equals 1 squared, which is 1. And then the last part to do is just add 1 to both sides, which means x, in fact, equals 2. All right, so the last one, again, there's that one, x equals 2. And the last one is going to be number 5. And when you first see this, you're going to probably freak out just a little bit. Square root of 2x plus 12 equals the square root of 5x plus 27. Oh my goodness gracious, what in the world? Mr. Hamilton, we've got radicals on both sides now. What I want you to notice is on this left-hand side, okay, I have a radical and it does not have anything else with it. So there's nothing else that needs to be moved to the other side. So let's just think about, well, how do I get rid of this radical? That's really the important part, right? Because I've got to isolate the x. Well, I have to square this side, right? But if I square this side, I have to also do the same thing to the other side. So that actually means I need to square this as well. Well, again, this looks really, really complicated, but think about what really just happened. When I square a square root, all of that goes away. And when I square a square root over here, this also goes away. So the only thing I have left really is 2x plus 12 equals 5x plus 27, which is just an equation with variables on both sides, which we've solved tons of different times. I like to keep positive numbers, so I'm going to subtract 2x from both sides. So that leaves me with 12 equals 3x plus 27. Then I need to subtract 27 from both sides. So that gives me negative 15 equals 3x divided by 3. All right. Again, we've done this for a long time, so I know that you know how to do this. So x equals negative 5. Okay. So that would be our answer. X equals negative 5 for that equation that, again, looked very daunting, but when you square both things, you end up with something that we've actually solved numerous times in the past. So not very difficult. Again, you've got 15 problems on your practice. I've actually already did 5 on this video. So you've actually only got 10 left that you need to complete. So if you need any help, make sure to reach out to us and we'll be glad to help you. Thanks.